before we start to talk about the heart and its relationship to probably the first really fun organ system we get to, not that the digestive system wasn't fun or other things, but a lot of people seem to really like to talk about the cardiovascular system. Before we talk about that, we got to go back and think about how our body is put together. We've seen this picture before. Your body's water compartments. The compartment inside cells, intracellular fluid. All of the fluid that's floating around outside the cells that the cells exchange materials with. Interstitial fluid. And then finally, your blood plasma. And when we drew our picture in the digestive system, we made sure we included the digestive system as a tube running through the blood plasma, because whenever it should let me erase. There we go. Whenever we absorb something across the wall of your small intestines, it's absorbed into the blood plasma. And then that blood plasma can deliver those nutrients all over the body. In order to do that delivery, we have to have something that actually moves the blood around. And that's the function of the heart of the cardiovascular system, is to be, well, one, the pump that moves the plasma, and then two, the tubes that make sure all of that blood gets to and where it needs to be from and to. Hopefully you get the idea. So our focus in this chapter is really, how does the heart move around this one water compartment, move around the plasma so that we can get nutrients to all the cells of all the tissues of your body and get rid of waste products from those cells, from those tissues. But we've got to start with, well, if we've got this pump that's moving around all of this water compartment, the plasma, where do we find it? And the easiest answer is in the thoracic cavity. Thoracic, the thoracic cavity. It's located basically right in the middle of the thoracic cavity, underneath your sternum. It does poke out a little bit to the left side, and we'll talk about why it pokes out a little bit to the left side. But in all reality, it's right there, dab smack in the middle. More specific than thoracic cavity is a region within the thoracic cavity called the mediastinum, N-U-M. And this is kind of a carve-out between the lungs, where the heart is, in addition, the trachea of the respiratory system and the esophagus pass through the mediastinum. But that really is, the most specific answer is the mediastinum. That's where we find the heart. Well, where do we find the heart, the mediastinum? They're located less specifically in the thoracic cavity, protected by the rib cage, and probably most importantly, I wasn't sure what that would do, most importantly, the sternum that covers up and protects the heart. If we look more closely at where the heart propels blood, there are really two different places. And probably most of us already are aware that the heart is sometimes referred to as two different, or has two different sides, a right and a left. And each one of these sides delivers blood to a particular place, or we should say on a particular circuit. The two circuits are the pulmonary and systemic. Pulmonary, whenever you see the term pulmonary or pulmo, like a pulmonologist, think lungs. And the pulmonary circuit is the short circuit that takes blood to and back from the lungs. That's one of the two places your heart sends blood. The other place is to all the organ systems all the organ systems in your body. Hence, that's the systemic circuit. And without getting too far ahead of ourselves, we're going to quickly see that the right side of the heart is responsible for delivering blood to the lungs. The left side of the heart delivers blood everywhere else. The left side is the systemic circuit, or leads to the systemic circuit. The right side leads to the pulmonary circuit. And one last thing before we leave. Just a couple of anatomy terms that I'm not going to test you on, but we should be aware of. When we talk about the front, it's anterior. When we talk about the back, posterior. And any good diagram of the heart is either going to be labeled anterior or posterior. This one is anterior. We're looking at the front of this individual in this cartoon representation of the two circulatory circuits. When you look at any diagram picture of the anterior of the heart, this is my left, this would be the left side. So you always imagine, and it should be labeled, but if it's not labeled, always imagine, all right, I'm looking at it like I was looking at a person. That makes this left and that right. There's a much easier way to determine which side is the left side and which side is the right side of the heart, even if you don't know if you're looking at the anterior or posterior side. But we'll come back to that in a minute. Just for a little fun. Don't even need to change the markers. I don't know why I just did. Atom, molecule. Do you want to take a second to see if you can rip through them? Just pause it, see if you can. Did you do that? All right, you've got them now? Good. Molecule, organic, molecule, cell, tissue, organ, organ system. Finally, we get 11 organ systems together to make an organism. The heart is an organ. It's an organ made of two or more tissues put together to make a structure that plays a role in the cardiovascular system, a role in maintaining homeostasis, keeping everything pretty much the same all the time. The tissues are put together in the heart to make three distinct layers. The three layers of the heart cardium is pretty easy. Cardium refers to heart. The prefix epi means on top of. So the three layers are the epicardium, myocardium, and endocardium. The epicardium is the outermost layer of the heart. It is essentially the covering of the heart. It is a very thin layer of tissue that in a lot of ways just allows the heart to sit there in the mediastinum. And it's thin and it's smooth, so every time the heart moves around in there, it decreases or reduces friction. So you don't have to worry about the heart rubbing against other tissues and, eventually wearing a hole in something. The biggest, thickest layer of the heart is the myocardium. We haven't got to the muscular system yet, but the prefix myo means muscle. And the bulk of the heart is myocardium. If you lift a heart, pick up a heart, hold a heart, touch a heart, that mass that you feel, 95, 99% of the weight of the heart is the myocardium, because at its core, the heart is essentially just a muscle that contracts to push blood all over the body, either on the systemic circuit or on the pulmonary circuit. Lastly, the innermost layer, innermost layer. The endocardium is, again, it's another really thin layer. Like the epicardium, it's really, really smooth. And it lines the chambers of the heart. so that as blood moves through the heart, there isn't a lot of friction to slow that blood down due to the presence of endocardium. So we should start our understanding of the heart knowing that it consists of three layers. The three layers are the epicardium on the outside, the endocardium on the inside, both of which are a really thin layer of tissue, really, really smooth. The biggest, thickest, I don't know if most important is the right term, but the most abundant layer of the heart is the middle layer, the myocardium. And it is the action layer. It is the layer that does everything. Now, these three layers are put together into a four-chamber system. The four chambers consist of two on the top, 1, 2, and 2 on the bottom, 1, 2. The top chambers are the atria. The bottom chambers are the ventricles. Easy as that. One of the things we notice right away is the ventricles are much more developed than the atria. The ventricles are the bulk of the mass of the heart. If you ever see, you really can't appreciate how small the atria are compared to the ventricles in this little diagram. The atria are itty-bitty, teeny-tiny, insignificant compared to the ventricles, and we'll talk about the reason why a little bit later on. Separating the heart into a right and a left is, well, it's nothing special. It's just a layer of myocardium, the thick muscular layer of the heart. But this layer of myocardium separates the heart into right and left ventricles or right and left atria. It's called an interventricular septum or an interatrial septum, inter meaning between. The most important thing for us is we should be aware that we've got a fancy word. You paid a lot of money for the class, we should get some fancy words. We've got a fancy word that means structure between either the ventricles or the atria. They're called septa. Septa is plural, septum is singular. And then lastly, there are also valves associated with these chambers of the heart. Two sets. There's a pair of valves between the atria. There's an atria and the ventricle. There's the other one, atria, ventricle on the right side. And valves between the ventricle and the major vessel that it discharges blood through. So this valve right there is between the right ventricle and what we're going to see in a second is the pulmonary artery that takes blood away from the right side of the heart. This one right there is between the left ventricle and the aorta that takes blood off on systemic circulation. And then lastly on this side, these valves, or at least the ones between the atria and ventricle, and only the ones between the atria and the ventricles, have little tendinous structures that hold the valves, kind of anchor them to the wall of the ventricle so that when the ventricle contracts, the valves aren't forced in the wrong direction or prolapse, open the wrong way. And wow, that was a lot of information. I really feel like that was a lot of information. It can seem simple because, hey, there's a septum. It separates the two sides of the heart in a lot of ways. 4 chambers, 4 valves, chordae, tendineae, bloods go on places. What's it all about? This is my suggestion. Rather than thinking about this really complex, anatomically correct heart, I am going to introduce you to a friend of mine. My little friend, probably 70-75% of what you need to know for the heart in this class comes from this little friend. It's not a thing just to be looked at. It's a thing to work on, to do. So I would suggest in studying, practicing, creating your own little friend. I call mine cartoon heart. Now, one of the things about cartoon heart is not anatomically correct. So we need to be aware of that. He's a little bit, shy about it. He's a little self-conscious, so don't bring it up to him. But he's not anatomically correct. He is functionally correct. He does indicate where all of the structures are in relationship to each other, and it's a good tool for knowing how the heart is put together, especially in relation to the two circulatory circuits, and we'll see that. But just keep in mind, cartoon heart is not anatomically correct. So here we go. The heart consists of two sides. There is a right side and there is a left side. I chose the two colors that I did for reasons that hopefully will be obvious later. I don't know how I did that. That was awful. All right, let's start over from the beginning. There's a right side and there's a left side. This is how I usually do it. Maybe I'm going to have to be a little bit carefuler. But usually I feel like somebody's playing a trick on me. I don't know. We're never going to get through this. I don't know. Do you? Okay. One last, let me put that, maybe I'm touching that somehow, some way. I don't know. There's a right side, all right, right side. And there is a left side. We'll go ahead and do that. There's a right side. There's a left side. Again, not anatomically correct. Man, this is not the best cartoon heart I've ever drawn. That's okay. It doesn't really matter. And each side consists of, well, let's just start by naming the chambers. Each side consists of two chambers. There are the chambers up top and the chambers down below. The top chambers are the atrium. And this is the right side, so that would be the right atrium. I'm just going to abbreviate it. It's going to make it easier. And that would make this the left atrium. Brilliant. Below, we have the ventricles. So we're on the right side. That's the right ventricle. Over here, that would make this the left ventricle. Brilliant. Lungs? Yeah? There are two circuits that your heart distributes blood to. There is the circuit that consists of the lungs. That's the pulmonary circuit. And then there is the rest of your body. All of the other organs, organ systems of your body. Let's call that systemic because that's what its name is. The function of the heart is to deliver blood on these two circuits. And there is a major vessel that leaves either ventricle to distribute blood to either of these circuits. And that's the first big putting some things together. The ventricles are discharge chambers. And the function of the ventricle is to send blood off on one of these two circuits. On the left side, the left ventricle sends blood off to the systemic circuit. And the major vessel that the left ventricle discharges blood into when it contracts to move blood is the aorta. On the right side, when the right ventricle contracts, it sends blood off on the pulmonary circuit. And the major vessel that, the right ventricle delivers blood to when it contracts is the pulmonary artery. So we should definitely know these things. We should definitely know the left ventricle contracts to send blood to the body, to systemic circulation. And the major vessel that takes blood away from the left ventricle is the aorta. And it's the first vessel that's then going to go and branch and branch and branch to all the different pathways of the systemic circuit. On the right side, when the right ventricle contracts, it sends blood to the pulmonary circuit, and the major vessel that takes blood away from the right ventricle is the pulmonary artery, which then branches into right and left to send blood to the right and left lung. Brilliant. Maybe you'll notice we use two different colors here. We use blue and red. I use blue to represent oxygen-poor blood and red to represent oxygen-rich blood. I noticed this book in particular, I'm not crazy about this ever, but a lot of textbooks will use the term deoxygenated. I'm not a fan of the term deoxygenated blood because even when blood has been used by the tissues of your body and oxygen has been taken out of it, there's still a lot of oxygen left in it. So as opposed to deoxygenated blood, I just usually try to use the term oxygen-poor blood. They are interchangeable, but there's a reason I use oxygen-poor as opposed to deoxygenated. But I'm going to say that we've got oxygen-poor blood that's going from the right ventricle off the pulmonary artery to the lungs. At the lungs, we are going to branch into itty-bitty, teeny-tiny vessels called capillaries, and we'll talk more about the different types of vessels as we get into Chapter 10 on blood vessels. But for right now, maybe the only, arteries take blood away from the heart. Arteries always give rise to capillaries, where we exchange materials, and then capillaries merge together to form veins. So, there we go. So at the lungs, we exchange oxygen for carbon dioxide, and this oxygen-poor blood that was delivered to the lungs along the pulmonary artery, exchange oxygen for carbon dioxide becomes oxygen-rich blood, and then a major vessel then brings that blood back to the left atrium. That major vessel is the pulmonary. They didn't get real creative with the names here either, right? It's the pulmonary circuit to the lungs, pulmonary artery, pulmonary veins. But the pulmonary veins then empty into the left atria. And that's what the function of the atria are. They are receiving chambers. Ventricles are discharge chambers. Atria are receiving chambers. And the pulmonary artery delivers blood back to the left atria. On the systemic circuit, the left ventricle has delivered oxygen-rich blood where all the tissues of the body that are exercising and doing all kinds of great fun things are going to take the oxygen out of that blood, dump in carbon dioxide, and return oxygen-poor blood back to the right atrium. The major vessel that takes blood from systemic circulation directly back into the right atrium is the vena cava. As a matter of fact, there are two. There's a superior vena cava, which drains everything that was above the heart, and an inferior vena cava, which brings blood back from all of the organs that were below the heart. Oh, and isn't this nice? We kind of have a network and a pretty obvious pathway with directions that blood flow. And I would definitely be aware, one, your heart is broken up into two halves, a right half and a left half. I suppose you could also break it up into top and a bottom. And sometimes we do and will. But right now, a right and a left. The left side is responsible for discharging blood on the systemic circuit, the right side, the pulmonary circuit, but they ultimately make this kind of loop that goes round and round and round and round, and we should know the order of all the structures. We should know that if we start in the left ventricle, from the left ventricle we'll leave via the aorta. The aorta is off to systemic circulation. We exchange oxygen for carbon dioxide, and the blood that was in systemic circulation ultimately returns to the heart via the vena cava into the right atrium. From the right atrium, we're going to move to the right ventricle, and from the right ventricle, we are taken to the lungs, the pulmonary circuit, at least initially on the pulmonary artery, exchange oxygen for carbon dioxide, become oxygen-rich blood, and return to the heart by the pulmonary veins, which empty into the left atrium, from the left atrium to left ventricle, and voila, brilliant. We go round and round. And we definitely should be able to identify this general flow. And we should definitely know maybe two more things. One, you'll notice that blood only goes from atria to the ventricles. Never from the right to the left or the left to the right directly, and never from the ventricles to the atria. And the reason for this is, one, there's a muscular septum in between the right and left side of the heart. We mentioned that earlier. And unless there's a defect in the septum, we're never going to see mixing or moving directly from the right to the left or the left to the right. Two, we always go atria, ventricles, major trunks, pulmonary artery, aorta, leaving the heart. We never go backwards. And the reason for this is because they're valves. And valves do exactly what you would think valves would do. They keep fluids, blood in this case, from moving backwards. On the left side of the heart, between the left atrium and the left ventricle, is the bicuspid valve. Also called the mitral valve sometimes. Also called the left atrioventricular or left AV valve. You should be able to go back and forth between all three. Bicuspid is probably the one you'll hear most often. I think left AV is the one that's most descriptive and easiest to understand. But definitely be aware that a lot of times it's also referred to as the mitral valve. On the right side, the valve between the right atrium and the right ventricle, is the tricuspid valve. These two valves, the left AV, the right AV, is everybody with me? The right AV, the left AV, or bicuspid, tricuspid, these valves have to be able to withstand the pressure that the ventricles generate to push blood. Well, if we come over here to the left side, because it's the most drastic, when the left ventricle contracts, it pushes blood everywhere in systemic circulation, from the top of my head to the tips of my toes, out to my fingertips, regardless of where these body parts are. The left ventricle has to contract with enough force to get blood everywhere in the body. It wants to go backwards when that left ventricle contracts, but the bicuspid valve prevents the blood from going backwards. One of the reasons it can do that and not wind up getting flipped the wrong direction is because of the presence of those chordate tendineae. Maybe I can go back a slide. There we go. The chordate tendineae anchor that valve to the wall of the right ventricle or the left ventricle, and prevent it from flapping backwards. Again, anatomically correct drawing of a heart. The major vessels leave the top. They don't stick out the sides. Cartoon heart is not anatomically correct. I drew these major trunks leaving out the sides of the heart. That's not the way it works. But for my little drawing that I can draw over and over and over again and practice with, this is really easy. And then I can just overlay, I know this isn't anatomically correct. It's not anatomically correct. But it is functionally correct. It goes from the left atrium to the left ventricle past the bicuspid valve. It goes from the left ventricle out the aorta on systemic circulation past these two valves that are located between the ventricles and the major vessels they force blood into when they contract are called SEMI, semilunar valves. On the left side, it's called, I know this is tough, the aortic semilunar valve, or sometimes it's just called the aortic valve. And on the right side, it's called, get this, the pulmonary semilunar valve, or sometimes just the pulmonary valve. This is cartoon heart. And we just went through the most important, I think, anatomy, at least the anatomy of the cardiovascular system we should start with. The basic structure of the heart in this four-chamber arrangement, a little bit of an understanding of why blood travels in one direction only in the heart with these four chambers, and the two major circuits that blood is delivered to by the left and the right side. Maybe, since we are finishing up talking on valves, one other thing that's not necessarily a takeaway from cartoon heart, which isn't anatomically correct, I have to think a little bit for this last one. The left ventricle has to deliver blood everywhere. The right ventricle has to deliver blood just to the lungs. They both have to move the same volume of blood every time they contract because you need the amount of blood coming to the heart and going away from the heart to be exactly the same, regardless of what circuit. Otherwise, you'd have one of the two circuits backing up. The lungs are pretty close to the heart. They're both there in the thoracic cavity. Systemic circulation is, well, it's everywhere. Because the left side has to distribute blood a lot farther than the right side, the left side has to be a lot stronger than the right side does. And the musculature, the myocardium of the left side of the heart, is a lot thicker and more durable than on the right side of the heart. So if we come back to this anatomically correct figure, and remember how I mentioned good drawings or good figures are always going to tell you if it's anterior or posterior. Well, this is anterior, which tells me this is the left, this is the right, but I could just scribble that out and look at myocardium, and see over here the myocardium is really, really thick. Over there it's considerably thinner. And because this is the thicker myocardium, I know that's the stronger side of the heart, that's the left side of the heart versus the right side of the heart. One last idea, just since we were talking about valves, the function of valves is to make sure the blood travels in one direction only. And we see valves primarily, well, they're at the heart. The two places we have valves are between the atria and ventricles and between the ventricles and major trunks or major arteries that they eject blood into. Here we have, this is anterior, posterior. This is the top of the heart. And they've basically cut through the atria. So we're kind of looking down and seeing the AV valves, the tricuspid on the right and the bicuspid on the left. And then we see this is the aorta, and that's the pulmonary vein. Again, anatomically correct heart doesn't look anything like cartoon heart. In an anatomically correct heart, the major vessels leave through the top. When the atria are contracting, the atria are forcing blood into the ventricles. And for that to happen, I know it's kind of obvious, but for that to happen, the AV valves, the bi and the tricuspid, have to be open. And that's what we're seeing here. And when the bicuspid and the tricuspid valve are open, that means the ventricles have to be relaxing because they are receiving blood. If they were contracting, they would need to be pushing blood away. So that while these tri and bicuspid valves are open, the semilunar valves by default are closed. And that makes sure that blood can't move backwards from either the aorta or the pulmonary artery into the ventricles. Then, when the ventricles contract, those semilunar valves open up because they are one-way streets to let blood flow away from the heart on either the pulmonary or the systemic circuit. The AV valves, the tri, 1, 2, 3, and the bicuspid valve, 1, 2, they have to be closed. And they're closed during this ejection phase when we're forcing blood away from the heart. So valves make sure blood travels in one direction and one direction only. The AV valves are between atria and ventricles. Semilunar valves are between ventricles and the major vessels that take blood away from the heart. The aorta on the left side, the pulmonary artery on the right side. We'll begin next time, I think, then, by talking about, well, what are some of the organs, or at least the most important organ that's going to receive blood from the heart, and what is it that regulates the heart, or for lack of a better term, what is it that makes the heart tick?